Here's my solution for problem 2 from the lesson on section 7.7, writing an exponential function from a graph. In problem number 2, we're asked to write an exponential equation to describe the graph passing through the points 2, 4, and 360. The first step is to substitute for x and y in the equation y equals a times b to the x power. Using the point 2, 4, I get the equation 4 equals a times b squared. And then using the other point, 3, 60, I get 60 equals a times b to the third. You might have noticed in example 1 that we didn't use substitution to solve the system like we did in the warm-up. Instead, I divided one equation by the other. We'll use that same method here, but you can still always use substitution if you prefer. So if I divide one equation by the other, I always write the equation with the greater exponent on the top. So I'll have 60 on the top of the 4 and a times b to the third above the ab squared. This will help me avoid having negative exponents when I do the next step. Then we'll reduce both sides as much as possible. On the left side, 60 divided by 4 is 15. On the right side, the a's will cancel out, and when I subtract exponents to reduce the b's, I just get b to the first. So this tells me that b is 15. Now that I know that b is 15, I can substitute that 15 in place of b in either of my equations to find a. I'll choose the one with the smaller exponent, because I think that's easier. So 4 equals a times 15 squared. 15 squared is 225, and it's multiplying by a, so I need to divide both sides by 225 to get a alone. This means a equals 4 over 225. Now the goal of this problem was to write an equation for the graph, so I still have to write my equation. So plugging in the values I just found for a and b into y equals a times b to the x, I get y equals 4 over 225 times 15 to the x power.